Good morning and good afternoon, everyone. I am Cynthia Perez, Director of Education at UTC. On behalf of UTC, welcome and thank you for attending this webinar. Navigating the Future of Utility Networks, Autonomous Utility Telecom, Real-Time Monitoring with Automatic AI-Enabled Command and Control, sponsored by Inghouse. Please note that attendees will be muted for the entirety of this webinar. However, you will certainly have an opportunity and are encouraged to ask questions. We ask that you submit your questions through the Q&A function, not the chat function. The chat function will not be monitored for questions. Please note that the Q&A function is intended for webinar-related questions and content only. Please note that after the webinar, you will receive an email from UTC that will contain a link to the webinar evaluation form. This is very important. You must complete the evaluation form to receive a certificate of attendance. You will earn 1 professional development hour for this webinar. The slides and recording will be available in networks within 1 week. And finally, next slide. And finally, today's presenters, Tom Carroll and John Neely will present the panel webinar. Will present the webinar. Type your questions as you think of them, and we will answer as many as we can. Remember, use the Q&A function to submit your questions. And now I'm happy to introduce Tom Carroll and John Neely.
Thank you so much. It's great to be here again with UTC. We're really excited about today's topic, very forward-looking topic indeed. And I'd like to also welcome my good friend and colleague, John Neely.
Hi, everyone. Thanks for taking the time to listen to this webinar today. This is my first time doing this with UTC, so I'm quite excited to be able to do this with Tom and Inghouse, and want to thank them and UTC for the opportunity.
Excellent. So a little bit about ourselves. My name, obviously Tom Carroll, but I'm an engineer. I've been an engineer pretty much my whole career, mostly in service assurance. I started out with Harris Corporation here in Melbourne, Florida, where I still live today. And I've been involved with information security, service assurance, and telecommunications pretty much my whole career here. And John?
Hey, I'm John Neely. I'm the Director of Business Development for Accentria. I've got a background, I have a degree in computer security and network technologies. So I have the technical background. I have about 9 years experience in telecom. And I just want to mention that I will be representing Accentria at UTC Region 9 upcoming in Spokane in September. So if anybody's going to be there, I'd be very, very excited to talk to them.
Excellent. I think we'll be there as well. So we'll see you there, John.
Sounds good.
Okay, so let's walk through the agenda quickly. So first, we want to introduce the ecosystem of utility telecoms, very complex, very diverse system of systems. One that we'll walk through step by step, and then we'll look at the moniker of service assurance, what that means, how that may apply to that ecosystem. Then we're going to drill down a little bit into the details there around the remote site monitoring and the automation around that, what's available today. We're kind of taking that snapshot of what's happening today in and around you, especially telecoms. We both have telecom utilities as customers. So this is one we're speaking from experience, and then we'll dive a little bit into our alliance and how we've been working together for over 15 years now. And then we'll transition the whole conversation to AI, and then we'll talk about this incredible velocity of AI into our lives, into our society, our culture right now. And then how that applies to the service assurance and the remote site monitoring. Then we're going to take that leap forward of what this looks like in the future. And then we'll follow up with questions in our conclusions at the end. And you know, as mentioned before, we will have Q&A, so we'll have poll questions, but you'll be able to ask questions at the end of the presentation. So to try and set expectations on this, you know, I'm from Florida, so like every good Floridian, I have a hurricane plan, one that prepares me for a single hurricane being without power for up to 4 days, food and water, hurricane shutters, trimming back trees, preparing every way you can for a hurricane. But in 2004, we were hit by 4 hurricanes in 43 days. 2 of those were near direct hits, which you're still in disaster recovery from the first one, getting hit by a second one, a third one, a fourth one. So the idea there is that, you can automate as much as possible. You can have preventative procedures in place, but it doesn't cover extreme natural disasters or events like this. And John, you're out on the West Coast. Just as recently as last year, you had something similar, right?
Yeah, yeah, absolutely. Unfortunately, on the West Coast here, we've got fire season now. So you do as much as you can prepare for it, but especially the wildfires last year in the LA area were pretty unprecedented, and you can't be fully prepared. Your plan is difficult to upkeep when you get something like that. Right before, during this event is not when you want to realize you're not prepared. You want to have a plan well beforehand. You want to make sure your monitoring solutions are robust and ready to go before these critical events hit, and they unfortunately will hit no matter your location in America. Just a matter of time until something happens that you need to be prepared for.
Right. And I mean, the technology and early warning systems since 2004 have improved significantly. I mean, I know from our perspective, we get early warnings like tropical storm warning, then you get hurricane warning, then you get tornado warnings, flood warnings. All of these are specific to counties, even areas, and then real-time feeds of what's happening now. I know similar to where the wildfires are and things like that. So there's almost sometimes even an information overload where you're trying to triage and figure out, okay, what do I do with this information that's coming in? But it is actually improving not only the response but the preparedness for people so that they can be instructed where to go, assuming that all the communication still exists. But from a utilities perspective, it helps them to quickly identify service outages and where to direct first responders so that they can restore those necessary and life-saving services. So,
absolutely.
Yeah. Okay, excellent. So what now we want to talk about this ecosystem, right? So this is obviously very, very complex system. And, you still have legacy systems out there, state-of-the-art systems, a combination of both. Resiliency, high availability. The utility telecom arena is one that is by design meant to be very robust because critical services rely on their services. And, from our perspective, we're always looking at the service down, whatever that service might be, your electrical service, water, gas, but the telecoms that make sure those services are in place. You have a SCADA network, you have maybe a P25, a radio network, a microwave transmission network, but there's a lot more to it than that, right, John?
Yeah, no, absolutely. There's all these disparate systems out there, and a lot of times people want to silo them and kind of think of them as their own thing. But really, to have the best disaster preparedness and to make sure your system's as robust as possible, they need to be harmoniously working together. Um, Having them siloed just makes the response more difficult. It makes being prepared more difficult. So finding a solution that can monitor and give you all this information at the site level, at a network wide level, is very critical to making sure that you're prepared for these events. And during the event, you can respond as well as you can.
Right. So in looking at this diagram, you can see that, quickly you could have a dozen different silos of information all the way down to even at the remote site where you have security controls or power systems and or all the way up to a weather emergency broadcast system like we were just talking about, right? So each and every one of those things by itself may be monitored independently, but like you say, it's really being able to bring all this together to make informed decisions and be able to really manage and even prevent outages where you can.
Yeah, correct. If even one of these silos goes down, it just cascades into complete failure of the total network. So keeping them all online is critical, and having the visibility into all of them is critical.
Excellent. Excellent. Okay, so right now we're going to move into the service assurance, and that's a word that we really use that talks about, like, FCAPS is a familiar term in utility space around the monitoring of end-to-end components that make up your utility service, your telecoms specifically, right? So the core, the foundational one, there's always been fault management, just understanding what's the alarm condition of the network, especially the ones that can impact service. We always talk about it in terms of real time, because you need to know as soon as it happens, where it happens, what the response should be. For that means you have to be able to cover multiple protocols, multiple vendors, multiple domains. So you think about that spoked wheel, right? They're not all just SNMP devices. Some of those are talking TL1, old school protocols, or maybe even their state-of-the-art web services interfaces, or next gen APIs. The key to this foundation is us bringing all that information and normalizing it, and standardizing apples to apples, so that a critical or a number 5 alarm mean the same thing to the end user, to the people who are in operations. Also, being able to enrich that alarm with location-based information, service-based information, customer-based information that may not exist when the alarm comes into the system. You can actually filter out unwanted alarms, and then also filter in the critical alarms, so that you don't have this alarm overload condition where you have so many outstanding alarms you don't know where to go. The sister to that really is performance management, which is more proactive, where you're reaching out and grabbing KPI information, their numbers, what's your utilization, what's the temperature in a room, what's the DC voltage at site 132. These are all performance metrics that aren't alarm conditions in themselves. Performance management gathers the information, assigns them a threshold, whether it's above or below normal operating parameters, and then it creates an alarm which ends up in the real-time fault management system. So you can see how these two things work closely together to give you an understanding. One is more reactive, fault management is more reactive, performance management a little more proactive, that can give you a leading indicator that a fault is going to occur sometime in the future. Being able to collect that information, baseline that information, and then understand what's normal every day is key to performance and service quality. Now, both of those contribute to event correlations, right? So there's a couple different kinds of correlation. One is looking at the alarms only without any context, looking at how many alarms are occurring within a period of time on a single device, a service, a location. And then there's also root cause analysis, which takes the topology of the network, understands the redundancies, and can assign the criticality based on the impact of that, and identify what really was the root cause of the problem that's causing all these other alarms to occur, and allows you to filter those out simply. Now that's been around a long time, so that's not new or anything cutting edge. It's something that we delivered for many years. This all spills into trouble workflow management, where once something happens or you want to make a change in the network, there's a system of record that says, here's what happened. As somebody gets assigned, that team or person has to react, put in their input, and then a response team goes and fixes or manages the incident to closure, and then somebody evaluates whether that's really occurred or not. And so there's, anytime during the day, you're going to have dozens, hundreds of different tickets assigned to different people, and they're going through day to day, but that's really the metric that kicks off SLAs and lets people know what the status of their service is. Many Many people have online systems where customers can go in and look at the status of their ticket or whether there's an outage in an area. That's all in this same domain. And lastly is comprehensive end-to-end reporting and dashboards. The old school method of reporting is you create a PDF report and you email it to somebody, or you automate the emailing to somebody, daily, weekly, monthly report maybe. That's all changed now, and it's really around real-time interactive dashboards that are up to the minute, so that those same reports are no longer emailed. They're a link that you go to and interact with the data, and you want to see what that data looked like a year ago. It's all available at your fingertips. Much more elegant, much more powerful to decision makers. It provides transparency to what's going on in the network, from KPIs at how's my business running to what's the voltage at site 123. It's all there within a centralized dashboarding system, and that's one we use internally at Enghouse for help desk metrics, for performance metrics of the business as well. So definitely an interesting time in reporting, but the real value there is on what it can report upon, right? So if you have all your different disparate business systems, the dashboard can actually go out to each one individually and retrieve that data, so that you can have real-time data next to historical data coming from different systems with the same context, so that, like I said, just provides transparency as to what the business is doing. So now we want to drill down into the other aspect of that, the remote site monitoring. And John, I'll turn this over to you.
Okay, thank you, Tom. Yeah, so for our point of view, monitoring everything at these remote sites is critical. If you got the best power monitoring in the world, it's still like, if your environmental systems like HVAC goes down, it's not enough. You need to have those working together. Also, across these networks, it's very uncommon to have the same make and model of each subsystem. So like HVAC setup system or DC rectifier. So finding a way to gather the same information from the different makes and models, normalize the data, make sure the data is uniform going up to the single pane of glass of the management software, gives you a huge advantage in being able to look at your network as a whole, being able to monitor each site as the same, instead of having a different solution, different way you do it for different types of sites. That gets out of hand very, very quickly. And this isn't just for monitoring anymore. With edge computing, it's also a lot about control, down network control, being able to do things like change HVAC settings, start and stop your generators, open a door, whatever it may be. And this really allows you to, once you get the input and then you also have the output control, it really allows you to take full advantage of machine-to-machine learning, edge computing, and now AI, looking into the future. So, from our point of view, data normalization is absolutely critical to ensuring that your network is working as good as it should. Yeah, next slide, Tom. All right, so we tend to break it up into power, environmental, and security. But in reality, all of these work hand in hand, and having a solution that ties them all together is hugely important. For example, AC power monitoring, when combined with HVAC monitoring and HVAC control, gives you the granular data that you need to significantly cut power usage by the HVAC systems. It's a very low-hanging fruit for many of our clients. The HVAC systems is an OpEx expense that you can easily cut back once you start to gather up this data, and also have the ability to control the HVAC. We do this very often nowadays, with more of a machine-to-machine learning than AI, but it's definitely moving towards more AI. Just those reiterative algorithms to be able to determine slight changes in HVAC settings to optimize power usage is very critical. Another example is, many people think of IP cameras as security, which they certainly are. You want to know if somebody's loitering around your site, if somebody's breaking into the site. You want to make sure that the people at the site are the people that are allowed to be there, the techs. But we also use the IP cameras a lot for monitoring the other systems post disaster. You know, after a hurricane, after a fire, just because something's not online doesn't mean it's not at the site anymore. It just might need to be restarted. It might just, you know, it might still be there. Using IP cameras, you know, and especially the newer ones with a lot of these intelligence built in, we can set them to do things like zoom in at the AC power meter at the site to ensure that you're still getting AC power. You know, you can zoom in on the various subsystems and ensure that they're there, see if they're online. You can see the lights on them, make sure that they're online. Additionally, many of these sites have a ton of data that isn't being used. These new smart controllers provide a huge amount of data that's often not gathered at all. It's just sitting at the site unused. Picking up this data and normalizing it is something that our solution does very well and has low costs and huge OpEx returns. You know, you don't need to go out and upgrade every HVAC system to the new cutting edge controller to be able to get that same level of control using edge computing and IoT sensors. You know, we used to, a decade ago, it used to be the boy who cried wolf problem. We wanted a very limited a set of alarms, so the tech is not inundated with too many alarms, which is still the case. You know, you don't want to be sending them a message every 5-10 minutes. But now we see more and more people using this additional data, gathering up as much data as they can to have that telemetry data to be able to use AI and machine-to-machine learning to process that data and let you know what insights you can get from it, what you can do to make your network more resilient, and especially most importantly for disaster recovery, spot problems before they become a problem. You know, spot when your generator is going to fail by things like the battery voltage for the generator being too low or the oil pressure being too high. You know, these are great indicators that you need to get somebody to service that generator before you get that just straight gen fail alarm.
Excellent.
All right. Next slide, Tom. So kind of what we do today with telecom site automation, and you can do these things manually, but you can't really expect a human to react perfectly, especially in a disaster situation. So having the automation built into this control is important. You know, if it's just one site acting up, the tech can look at it and respond pretty well. But during a critical event, you know, they don't have the bandwidth to go and make all the right decisions, split-second right decisions to ensure that the site stays online for as long as possible. So being able to use edge computing, machine-to-machine learning, and AI to automate these is huge for our clients. You know, for example, starting and stopping generators, you can do that manually. You can put it on a schedule, which we highly recommend you do. But you know, when a hurricane is going to make landfall and you have that map of where it's going to hit, you can go ahead and exercise all your generators a day before it makes landfall. You can gather up that report on what might be the issue, which ones aren't working, which ones have those indicators that they will fail soon. You can go ahead and do things like load shedding. You can take non-critical equipment offline to optimize site uptime when you're running off batteries or generators. You can restart AC and DC equipment without needing to get somebody out at the site. You know, especially during the California wildfires, this was huge. There's huge swaths of the network that you just couldn't access. There's fires around it. Those roads are closed. There's no way for you to get in there. So having that visibility and that way to do this remotely allows those sites to remain online and still work during these critical events. And then the HVAC economizer one, you know, you're taking in those independent environmental aspects and combining it with your HVAC data, it allows us to use it in economizer mode, just blow in the cold air from outside instead of running those HVACs using up additional power when that's not necessarily needed. Next slide, Tom.
Okay, we reached our first poll of the presentation. So I think you should get a pop-up that, there you go.
There we go.
So we'll give like 15 20 seconds for you to fill that out. And we'll display the results and discuss it. Okay.
Okay.
Interesting. Yeah, I expect most people would have some sort of monitoring. I think the majority looking at 61% have it done. Some sort of means they have some of it done, probably the most critical systems that they need to automate, some planning, and then some no. So this may be of interest in how we make this happen, with somebody like Centria that can be the hands and the eyes, the ears, and the hands that can help automate this sort of stuff, and real-time monitoring all the way down to the door alarm. So interesting. You got any thoughts, John?
No, absolutely. Yeah, we do experience that most people have some sort of monitoring, but oftentimes, that's kind of that passive picking up a contact when something fails. Um, and a lot of people are okay with that until a critical event, at which point you understand that you need more monitoring. So I'll just reiterate that, implementing these end-to-end real-time monitoring solutions before these disaster events is saves you an incredible amount of time and money during the event and recovering after the event.
Yeah, it's a good discipline, especially if you're planning on using AI in the future. The end-to-end nature and the normalization, the data collection, the cleansing, the filtering, you're doing a lot of legwork that most people have to do independently when they're implementing AI. You have to do a dump of this system, a dump of that system, try to merge it together, and much more difficult than if you're already doing it. So if you're already doing it, you're ahead of the game, and you're preparing for the AI inevitability, I think. So it's a good
Yeah,
idea.
absolutely.
Okay. So this has definitely been, for me, good. I've been here for that long. The Enchausen Centria partnership has been one that's been great, because Enchaus, we were always looking for that last mile, call it last mile monitoring. We were always very in tune and able to do network equipment, service level down. But when it comes to remote site monitoring, you have to have an Accentria to be the hands, the eyes, and the ears at every remote site, and be able to pull these type of metrics into a single pane of glass, right? So this is an example of us integrated together, where the network is on the left-hand side, the middle matrix there, that is a matrix of all the different remote sites. We're drilling down into the remote site management here and pulling together all these different metrics of, hey, what's the highest level alarm, all the alarms at any given site, but more importantly, being able to drill down and see the actual details on contact closures, relays, analog and temperature, humidity values, power values, and even fuel levels, right? So being able to analyze and monitor that data. Yeah, what do you think, John?
No, I agree. The single pane of glass and the ability to drill down to see what's happening at a site level, working together is an incredible tool. If you've got the best network-wide monitoring, but all you're doing is picking up like 4 to 8 contact alarms, it's still not that great at a site level if you're monitoring everything at a site level, but you need to pull up each individual site to see what's really going on. You can't respond in any sort of good time using that method. So having that ability to view your network as a whole, and then drill down into sub portions of it, and then drill down into the individual sites gives you an edge that monitoring these things that you just don't get using either one by itself.
Absolutely.
Yeah.
I was going to say, let's look at a drill down real quick. So here's
Mhm.
what that looks like. And notice that we do have interactive buttons here that are pre-programmed to toggle relays or synchronize alarms. The reason you need something like that is if you do have a network outage to the site, or you're installing a new piece of equipment and you want to synchronize the alarms that are outstanding. That's what these are for. And it's also to provide additional details on each and every RTU and on each and every site. So this is one that everything you see here is automatically discovered from the site boss RTU and presented here. So if there's a different site that has different contact closures and relays configured, it'll show something different programmatically. You don't have to create this yourself. It's fully auto discovered and presented in this way.
Mm-hmm. No, absolutely. And this drill down also allows you to view that kind of non-alarm data, the telemetry data that is hugely important to determine why sites might be not operating as efficiently as possible, but aren't operating so badly that you're going to get a critical failure alarm. So this allows us oftentimes to see things like techs going into the site and changing the HVAC settings to be more comfortable while they're there, and then not changing them back when they leave. Without a solution like this, that might just run indefinitely, eating up power that you don't need to spend. Using this whole unified solution, you can spot those problems and fix them right away, ensuring that you're as resilient and efficient as possible.
Yeah, excellent. Okay, now we're going to transition over to the next poll question, and you'll get another pop-up. And now this one is about automating common recurring tasks. We'll see what comes up. Oh, that's actually really good.
Yes.
Yeah, partially I think it is a good go between there, and kind of what I expected, right? And the topic of today, right, autonomy, this is a good start. Some yes, some no, but mainly partially.
Mm-hmm. Mm-hmm. Yeah, and this is what we generally see out there in the real world. A lot of people get comfortable with the slight automation that they have. Um, because it works perfectly fine for day-to-day usage. Their techs get in a routine that's comfortable for them, and when it's a normal operating time and one site's being weird, just being able to do these actions manually, it's fine. But it is really looking towards those critical network-wide failures that really starts to fall apart. If you need to automate things network wide during a hurricane, it quickly becomes a problem for techs to keep up with. So we always push our clients to continue to automate as many of these functionalities as possible. And a lot of times we'll kind of have a fail safe. They still have the day-to-day control, but during an event, you can set like a higher threshold for something, like instead of just a high temp. Once you get to a very high temp, then automation kicks in and does what it needs to do to cool down the site.
Right, as a fail-safe,
As
absolutely.
a fail-safe, absolutely.
Yeah, and I know from a utility perspective, I've been working with utilities most of my career, that the generator run one is probably the number one thing that everybody automates. Generator run Wednesday at 2 o'clock in the afternoon, exercising the generator so you don't have to drive out to the remote side and do it manually. I think that one is very common, but there are other things, like you said, that are maybe it's a common task, but not one that you do regularly. Like, there's a spike in temperature, you need to turn that AC on before equipment gets damaged. So yeah, good point.
And then a kind of layer, talking about that generator example you just talked about, a layer on top of that, is many places in America, the Northeast, Northern California, now have dirty air days where you're not allowed to exercise the generator. So using a solution like ours, you can go ahead and just suppress that exercising during a day of high pollution, from a centralized location instead of having to send techs out to suppress it, or just eat the fines that you get for running the generators exercising on those days. Especially in Northern California, the burden is very much on the controller of the network to prove why that generator had to run those clean air days. And if you don't, the fines can be quite heavy.
Right. Good point. All right. Now we're going to transition the topic to AI. And I know AI and machine learning have been around for decades, literally even longer than that. It's been an incredible, almost astonishing, I don't know, transition over the last couple of years where the technology has matured significantly, the computing power has become affordable and ubiquitous, and the results have just been astonishing, astounding. I can't believe it, the velocity at which AI has become mainstream. Not only that, the velocity at which it's become a commodity of sorts, right? So you look at your mobile phone, your browser, your computer, all these are now having embedded AI components in them that are assisting your day-to-day life, whether you want them to or not, right? So it's kind of, I'll use the term inevitable. It's inevitable. Maybe it's avoidable if you unplug, but even then, I think the machine technologies, cars, appliances of all kind now will have AI embedded in them. It's its own industry, right? So it's become its own thing, and the economic impact of it is huge. I mean, it's massive, and the adoption by enterprise, by every major alphabet soup provider out there is complete, right? Even all service providers, any enterprise who has an online service has an AI component embedded into them. And so I don't know about you, John, I'm getting kind of there's the utopian, no, paradise, and then there's the dystopian 1984 Terminator kind of thing, So I'm an engineer, I'm kind of in between. I can see both sides of that. What do you think?
Oh, absolutely. I mean, from my point of view, I don't think the utility networks have much say on if it goes good or bad overall. Obviously hoping for the good, but like you're talking about, it's quickly becoming a commodity. It's something that you kind of have to implement at a business level to be competitive. I kind of see this as companies in the 90s that resisted computers for their employees. They thought it was just a phase. They think you can get by with old school, but obviously, it's not something that you can do. You're at a huge competitive disadvantage if you're not taking advantage of at least some of these tools. I'm not saying replace everybody with ChatGPT, but especially, like you said, these smaller purpose-built AI models are extremely powerful, and they're here today to help.
Yeah, and so that the whole Chat GPT thing, the generative AI, agentic AI, all these different models. So we're seeing more purpose-built, smaller models, more consumable, and then they'll basically just be services that you can subscribe to. They are today, but there's hundreds and hundreds of new companies that are just AI with a specific twist or for a specific application or type of AI, whether it's image processing or language processing or any and all of the above. It's really an amazing time to be alive. So here, let's move on to now let's look at the collision of AI and service assurance, right? So service assurance, fault management, performance management, basic correlation. We're now seeing, and we're proving this today. Enghouse also does catalyst projects with service providers to prove concepts, right? So we've done this with predictive fault management, simply by normalizing the data from different service providers, trouble ticketing data, alarm information, weather temperature conditions. And after training a specific purpose-built model, being able to predict what the next alarms are going to be with high level of accuracy. It's actually quite amazing that you get to that point rather quickly. And then you take the same thing with performance management, and now it's not just about managing the KPIs that are coming, but it's about optimizing them before they even start going out of balance, out of trend. And then that ties directly with the next component, which is closed loop, right? So you're predicting faults in the hopes of preventing them, but closed loop is when a fault does happen, being able to auto provision, auto modify the configuration of the network within certain parameters to correct and fine tune the service, right? And now we're talking about self-healing networks, which are a natural outtake of that as well. And then as far as the whole trouble management, your day-to-day, this is already being implemented in many help desks today as chatbots, AI assistants that tell the operators, hey, your customers' elevated voice patterns and the words that they're using, you want to say this, or here's some content that you can provide for this customer that will help de-escalate the situation or help resolve it to their satisfaction. So this goes all the way to the remote side, John.
No, absolutely. In the past, you monitor your KPIs, you see when your KPI is failing and you react to it. But using these models now, we can detect trends when you're reaching the limit of whatever indicator that may run up against an SLA or whatever it is. So you can spot these issues before it gets to contractual issues. These models are iterative; they're constantly learning. So during the last event, critical failure event, it'll gather a lot of data and allow you to kind of spot these issues before they become an issue next time. Say the site temperature is trending in this certain direction, and that tells us X, Y, and Z, and now we can ingest that data and give you ways to cut these problems off at the pass before it becomes a contractual issue. We also see a lot of people, kind of doing these models to see how sites will react in critical events. Combining a big thing about AI is combining all this data and having the AI tools ingest it. So seeing which sites are more prone to fail depending on what the weather conditions are supposed to be like, the height of the site, and historical data about what happened at those sites. It can help you see which sites are more critical to fail. They might need additional systems to help them remain online, and ensure that they're the most protected. It also lets you know which sites might need out-of-band access. These remote sites that the hub that they're going through is one of the ones that fails. Maybe the site needs remote access with a cellular modem or something to ensure that you still have access to the site during these critical events.
Absolutely. Good point. Now we're looking more at the preventative side of the house. These are the more what I would call advanced topics. The previous ones were ones that have been around for a while, and if you're looking at doing AI, are definitely, I think, the more achievable things like alarm prediction and automation around that are ones that you have the tools needed. These are a little bit more advanced. So computer image analysis is one that using AI to detect degradations in infrastructure or failure points based on imagery like drone images, right? So there's a lot of critical infrastructure that supports the network out there. You have towers, bridges, buildings, things that you have to inspect. Talk about maybe a common task that you can help automate, but to actually take the images and analyze them with AI so that you can compare the current image with the previous one and then the future ones, to identify those cracks maybe or things that might be prone to failure, right? So you can analyze those, and instead of having just a regular human pair of eyes look for something that's not there, then you can do that also with satellite imagery as well. So we have in Florida, we have a growing season that lasts all year long, and vegetation is one of the things that causes service outages, especially for electric utilities. It's a pet peeve of mine. We have, neighbors that let their trees grow into the power lines, and every time there's a hurricane, the tree takes out the transformer, and the whole neighborhood's without power just for that reason alone. There's been a lot of preventative work around that being done now, especially after those hurricanes, where FPL hires a contractor. They come in and once a year, once every other year, they come and clean the lines for everybody. There's no additional charge to us, but again, it's one of those preventative things based on satellite imagery, which you can subscribe to today. So there's plenty of high resolution satellite services where you can task a satellite to give you a very high detailed grid of your choosing, and you can pay a subscription and have the same image every month or on any frequency or one time. So there's the ability to have this information out there is it's a fantastic time for including this into your strategy. And it also helps with the second part of the AI digital twins. And this is one that we always used in security as to when you're doing auto discovery of your own network, the vendor, the MIB, all the details around it. It's discovering something that's not discoverable, but that you can determine it's there based on ingesting the network traffic. And so you start building a virtual replica of your network by traffic data and log files as to what's connected to what's communicating with what, and then classifying into, creating a topology map of that. But the pro side of that is being able to identify single points of failure, or the dark side of that is rogue devices that shouldn't be on your network in the first place. And that also includes the Wi-Fi aspect of it, whether it's not just a fixed line, but that as well. And then the same is true for remote site as well.
Yeah, no, absolutely. The ability to generate service tickets based off like non-alarms is a huge one. Predicting when generators or when HVACs are going to fail by the AI tool ingesting all the data from those, and letting you know before there's an outage, so you can get somebody out there to service that generator, that HVAC. Compare the power outages to weather patterns is another big one. You can get some very, very very granular micro data for weather patterns nowadays, very detailed on wind speed in particular. That gives you an idea of where power outages may occur in your network. And once again, it's AI model, so it's constantly improving on itself. And each time one of these events happens, you get a better model to be able to predict these. Another one that we've recently started looking into this one for this is to create reports on which subsystems, which makes and models of subsystems are most efficient, and it gives you some really granular data depending on like the environment. For example, like this version of HVAC may work better in the south. There are places where humidity is going to be above a certain percent, but for the Southwest, where it's a dry heat, these HVACs may perform better. We can generate these reports that allow you to compare these systems very granularly and see which ones are working best for you.
Excellent. And then we'll do our last poll question now. That's what I expected. John, what do you think?
Yep. No, this is what I was expecting. If you're on this call, you're doing some research into this. It's something that people need to do, and it is very much in its infancy, despite AI and machine learning existing for a long time. Like Tom said, it's really boomed over the last couple of years, and it's getting to the point where it has these very, very valuable, powerful tools for people to use, instead of just being more of a chat bot that you can chat to and tell it how your day was, or have it write an
Right.
email for you.
Yeah, that's it's interesting one, that between researching and planning, very closely related there, and that's kind of what I expect as this is moving so quickly now and becoming so affordable and ubiquitous that it becomes more achievable. So that's what I expected
Mhm.
as well. Okay, let's move on. So to kind of drill down into what we've been doing with AI, and these are actual projects, proof of concepts that included service providers. So every time you do a TM form catalyst, you need to have two service providers, right? So this is like Do in Dubai or Sri Lanka Telecom, others that are the champions of the project. And we have been started this in 2017 with the one that was really around alarm prediction, right? It was a predictive analysis engine that based on historical data, but then to one, not only predict when it was going to occur, but two, to be able to automate a response, a reconfiguration, a reactivation of a network device to prevent the outage in the future. That one was very interesting, really what kind of started us on our journey down AI. We did another one in 2020 around voice activated responses, asking for, what is the highest risk for outage in my network, and have the results display on the screen. Just last week, we were in Copenhagen for the TM Forum, and just the 17th and 19th last week. The name of our catalyst was Omnibus, right? And so this one was a unique take on that, because what it really did was around, yes, of course, it was KPI management and alarm correlation, but it was around the response, right? It was around the best practices. And it was meant to, one, guide inexperienced users into, hey, here's what the experts do, right? Here's the appropriate response to what you're looking at. Two, it reminds those experts what the approved procedures are for anything, especially if they're not reacting in a way that's already been pre-approved. But one of the most powerful things out of all this, I think, is talk about a common task that you have to do every day: documentation. It fills in the gaps along the way of places where you're supposed to document what was happening, and it takes that tedious nature out of the documentation of what happened, what do we do, what was the outcome, and then it learns from all of that and moves forward. So if you look at the diagram from left to right, you can see we have quite a diverse set of inputs into this system, and then you had the normal you know qualifying the data, training, evaluating, visualizing. Then you get to the predictive and action stages. These actions are where we would notify an Essentria that says, please reset this device, right? So we're taking that wealth of data that we get from Essentria and from the rest of the network, combine it together, and create this closed loop of action using AI. So this is something that's been one, many years in the making, but two, something that we've been able to prove with real data, real customers today. So very, very exciting. And John, you see how this applies to directly to you, right?
Yeah, no, absolutely. We need that. You're going to need that hardware at the site level. You're going to need that monitoring at the site level, and you also need that computing at the site level. You need something out there to normalize the data. You need a device that you can send controls to. And I think part of AI is having those open protocols, having open data that can be ingested by a tool easily, providing it in that form, and then giving that tool, the in-house tool, the ability to give commands to the site boss and implement them at the site level, and then have the site boss gather up the data again, use the edge computing to be able to send it back, and just have that continuous loop of constantly improving your network and making sure it's as resilient and as efficient as possible.
Excellent, excellent. So here we'll jump to the autonomous utility network, and basically becomes our conclusion here, is that where this is going, and it's happening quickly. I mean, this is not many years in the future, where networking equipment will be AI native, right? So this will be AI talking to AI at a layer above the core network, right? So we're going to need a new network OSI model that has AI at the top that does something different, right? So this is autonomous, agentic things are happening, and the models for this are purpose-built, well-defined, small consumable models. And this might be an interesting thing for UTC to help define what a utility AI model looks like in the future. You know, you got end-to-end real-time monitoring, trend detection, security, power savings, and, you know, predictive actions across the network. So definitely where we see that going. And John, from your perspective?
Hmm. No, exactly. We just see more and more of this autonomy being added in using AI. So, for example, we've talked a bit about being able to change HVAC settings remotely. We have clients now that have kind of moved towards two HVAC settings, depending on the season. You've got your summer, spring, and your fall, winter settings to ensure that the power is optimized. In the future, we see that connecting to an API of a weather service, being able to ingest that data and make micro changes for the HVAC automatically to just continually, change it a little bit each day or multiple times a day to increase power usage. Then we see the automation for self healing, spotting these issues before they become an issue, being able to restart this equipment. Um, you know, do these micro tasks very quickly and efficiently to self heal your network, and then it's like self documentation, like it says there. We've seen people move towards using AI enabled cameras to be able to do visual inspections, either to get a quicker police response in terms of theft, to be able to do the camera light inspections using cameras instead of sending people to those sites. And all this is tied to these AI tools that these cameras provide now. Like you said, it's going to be another layer of AI with all these systems on top having some sort of AI that talk to each other, that really can give you a very powerful and autonomous network.
Excellent. I know we're running out of time here, so we'll quickly jump to the conclusion and question. So just in parting, I used the word a couple times. I think AI is inevitable, especially the complexity and the growth of networks in general, but the utility network for sure. It's a powerful tool. It's not meant to replace staff. It's help them to do their job better, faster, more efficiently. And John?
Yeah, AI is here. We're not going to be able to replace it. Like I said, it's like trying to get away from computers in the 90s. We need to embrace it and find ways that it works best for us. And to do that, you need the full end-to-end control of the network. You need the high-level network view. You need the single pane of glass. You need the ability to drill down in the subportions of your network. You need the ability to drill down into the individual side of the network, and all those will have certain AI functions that come with them in the future that allow these networks to be more resilient, self-healing, and more efficient.
Excellent. Thank you. So I think we have time for maybe a couple questions.
Okay, I have a question right here. How can I take advantage of AI without building my own data center?
All right, I'll start with that one, John. So
Okay.
right now, the to do AI 10 years ago, you needed to have that. Today, the like ChatGPT is one example where you can do infinite input, infinite output, generative AI things. So the same is very much true, that they're out there that you can subscribe and or license a small purpose-built AI model as an online service, one that you don't need to have any infrastructure, cloud-based service where you provide your data to it, and it provides you the results out. Now, there is some legwork in there. There's a long road to define the training, the expected input and expected output there. but there's models that are going to be arriving soon that are exactly what you need without having to do anything. You just give it your data and it gives you the output. So that's something that's nearly available today. Okay.
John, do you have anything to follow?
No, I think Tom answered that one pretty well.
Okay. Can in-house and Accentria do some of this automation today without AI?
So why don't you take that one, John?
Yeah, absolutely. You know, we've been doing this for 15, 20 years using machine-to-machine learning. You know, just kind of more simple algorithms that are just going to repeat and constantly improve. But the big advantage of AI is that it allows all these data points to be gathered and compared more as a whole instead of siloed into individual things like power, security, environment. It can take all of those into a whole and be able to give you better automation using AI in the future.
Yeah, and I'll follow up, John, with the if you looked at the drill down to the site boss management console, there were buttons there that allowed you to, if you wanted to, manually push those, reset devices, check status, check connectivity. But those same ones, through a script-based what I would call interface, where you define the condition where you want it to occur automatically, that's available today.
Okay, I have one last question. What's the difference between the utility AI model versus something like ChatGPT?
Okay. So
Yeah,
the utility AI model is going to be much more narrow in scope. You know, it's going to be specific to what utilities need, whereas ChatGPT is essentially a language learning model. So it's trying to speak like a human would speak, to come up with answers like a human would come up with answers. Whereas these utility ones are going to come up with solutions like a utility tech would come up with a solution, but better. Give you tools to more easily monitor the sites that you're responsible for, and give you automation to take some of the burden off the techs in terms of having to do all these things manually. You got anything to add to that, Tom?
Yeah, absolutely. So it's, you know, ChatGPT is infinite input, infinite output. The purpose-built utility AI model is specific, discrete, limited number of inputs, and then discrete number of outputs, right? So it's purpose-built, smaller, faster, more affordable.
Okay, that's all I have. Thank you, Tom, and thank you, John. Just another reminder that the presentation slides and recording will be available in Networks within a week. Once again, I want to thank our sponsor, In-House Networks, and the speakers, Tom Carroll and John Neely, for their informative presentation. And thank you all for attending. Have a great day, everyone. Thanks,
Thank you.
Tom and
Thank
John.
you, everybody.
Thank you.
Thank you, everybody.